Well, good morning, everyone. Well, pleasure to be here. So I'm going to be talking about securing a Kafka cluster using the Vault and the Vault PKI secret engine. So my name is Mateus, as you mentioned. So this is a real-life example. So this is something that we did for one of our customers. So hopefully you should take some lessons out of this. So I'll be doing a demo. So it'll be we're gonna actually show something so you can actually see that working. And by the end of the talk, you should have a better understanding how you can actually use this for not just Kafka, but for other services. Because I'm going to talk about PKI, I'm kind of assuming that there's some basic understanding of how PKI works. That's actually explaining PKI. It's a talk in itself, or many talks. So I'm just going to assume that there's some basic knowledge of certificates. Okay, first thing, let me just introduce myself properly. So my name is Mateus Pimenta. I'm a lead consultant at OpenCredo. I have more than 15 years of experience in software engineering in areas development like architecture, infrastructure, and DevOps. We are at OpenCredo. We are a consultancy, and we help companies, our clients, to solve problems in the areas of cloud native applications and data engineering. We are HashiCorp and Confluent partners. And having said that, so if you have any further questions or anything else, so you can just ping me on Twitter. So the agenda for today, so I'm just going to start a bit of backgrounds, giving you the motivation. Why would you want to do like a secure Kafka? I'm just going to run quickly about what you can actually do, what Kafka offers in terms of security, and just a little bit of the PKI, what the PKI means and what's the benefit. So I'm just getting a thing here, so let me just check. Okay. So just continue. Then I'll jump into Vault just and explain a little bit of what the PKI, what's the Vault PKI is, and what the features you can get out of that. Then I'll jump into just a demo I have prepared already, a running cluster, and it's all secure. So, but we can actually play with it, see what we get. And then I'll end up with some conclusion. Just explain a few other things. So having said that, so let's get going. So the motivation. So this was, as I said, it was a real world example. So it's one of our clients in the financial sector, and they were building a multi-tenant platform. In terms of what it means is pretty much each tenant inside of the platform would have their own infrastructure. So it's a segregated infrastructure, and that means they will have containers or some other resources per tenant. But however, there's some aspects of the platform that would be shared, and one of those was the Kafka cluster, and that's pretty much requires for us some kind of a segregation inside the cluster. We didn't want data from client 1 or tenant 1 to be shared with tenant 2, so they should have their own streams of data. And to do that, we actually need to separate and have some kind of control access control on this data. So basically, the diagram just says that container 1 should only be accessing the data that it has access to, and not ever access tenant 2 data. In terms of other requirements that we also had, so we wanted to do, of course, in-flight data encryption. This was a cloud deployment, so we asked all the traffic going from container 1 to the cluster. The cluster was running on AWS EC2 instances, so that would be encrypted. So that screams TLS. The other things that we wanted, so auditing capabilities, and one of the key things, because was everyone has a different infrastructure or a segregated infrastructure. We really want to get something that was easy to manage, and we ideally something that you can generate like long and short-lived secrets if we can, or if we need to do secret rotation, that should be very easy to do. So this is kind of the background. in terms of, okay, well, what does Kafka offer to us? So Kafka itself has two components, the broker and zookeeper. The broker is the most interesting one. It is the one that I'm going to cover here in this presentation. So the brokers actually hold the data, the real data, the client data, the tenant data, and the options to authenticate. To authenticate to the broker, pretty much you have either TLS with mutual authentication, which is a client and server certificates, or you have a hybrid one, which is a TLS plus SASL. So that means a simple authentication and security layer. It's kind of it's a multiple, it has support for a few other types of authentication. And in terms of authorization, there's only one option in Kafka, which is Kafka ACLs. And pretty much an ACL would look like something like this. So you got like a principal which says, okay, container one from tenant one is allowed to perform some operation on some resource, like a topic in Kafka. As I mentioned, it's like zookeeper, it's just it holds metadata. I just want to mention here that if you are doing this, do pay attention that you do need to secure zookeeper. What we went, given the two options of authentication, what we actually decided to go for is the mutual authentication, because it was the simplest one for us, and it will give us the ability to dynamically generate secrets as long as we actually had some tool to do that for us. And the other options to use SASL they would require some kind of either a different infrastructure or some other extra infrastructure, or it will make our life difficult to rotate secrets. Right, so just a little bit, so we chose mutual authentication that is implemented usually with a PKI. So just a few details on the PKI itself, so probably already know this. But PKI was just a mature secure model that is deployed on the internet, so that's everyone's been using that. So you might have even noticed, but you've been using that. So it has strong security. So the idea is that no private keys are ever shared. So if you hold your private keys safely, then only brute force attacks would compromise the infrastructure. And one of the key things that we liked about the PKI is the expiration and revocation model. Expiration means that every certificate it has a time to live. So there's an expiration, and you say it's valid till tomorrow, or it's valid for just a few hours. And that was a very good, because one of our requirements is we really wanted to get short-lived secrets. So if that secret ever gets compromised, it will be just for a short period of time. However, PKI has some disadvantages, and I think that's where people actually get scared. So it's not really well understood. I think that's probably not the PKI's fault. It's probably more on the implementation. If you are trying to do that directly, or if you try to roll out your own PKI, it's difficult to get it done correctly. And as I said, because you have the tools are probably not the best ones, it's difficult to manage. So as I said, the tooling is also very low level. So you would see lots of binary or base 64 encoded certificates, there's standards all around. And at the end of the day, it's very difficult to troubleshoot. However, this is where actually Vault help us to basically to make those disadvantages effectively almost go away. So just a little bit now on Vault. So Vault, well, there's a previous talk talking about in detail about Vault, but just one line, the secret managed tool with some REST API, and we can use it to apply different security patterns. One of the things that Vault provides is a secret backend where you can, which is the Vault PKI backend, which you can use to generate certificates on the fly. There's a few other features like you can have certification authority hierarchy, so you can have a root CA, intermediate CAs. You can have many of those. So if you can deploy many CAs, you can also decentralize the CA, so you can have a cluster running your root CA and intermediate CA in a different one. If you do want to do that, so you can do that. It has some resilience and scalability properties and some also security benefits. And one of the good things about this is that you don't actually need to have signing certificates. You can have, but if you don't want to use a certificate signing requests, you don't need to do that, which is good. And for me, the key feature in the Vault PKI is roles. So basically, with a certain role, sorry, in a PKI, you can whoever holds access to Vault, it would have some kind of a role, and that role would restrict the common names of the principal or the person or the name of the certificate that you can generate and the time to leave of those certificates that you generate, which is a very nice thing, as we will see. And after that, so we also have the managed CRL, so which is the revocation part. So it's a good thing to have if you're ever deploy PKI. Just to make sure you configure that correctly. When you're using very short-lived certificates, you're probably not going to revoke anything. But if you do need to revoke, you probably need that setup. So now, well, I talked about Vault PKI, but I think that the best way to actually explore this is to go through a demo of that. So what I prepared something. So I'll just run through the setup. So what we're gonna see. And so if you want to get this, it's in my GitHub. The link is over here. So you can download the code and run it yourself. So pretty much what I'm going to show, I have a cluster here running a 3 nodes cluster, Kafka cluster. So each node has a different certificate, and they all authenticate between among themselves using TLS. So they all talk to each other with TLS, and the certificates that they use, they were generated by Vault. So each node has a Vault token that is able to generate certificates. On the client side, so Kafka clients, it's you can read as your application. So here's your microservice. So for the demo, I'm just going to use the Kafka CLI tool. But pretty much the client also has a token. It generates a certificate and uses this certificate to talk to the cluster. So this client then has a certificate. The server has a certificate. They can then authenticate themselves. So the server knows who the client is, and the client knows that he's connecting to the right cluster. In Vault, I have configured the following PKI structure. So I have like a root CA, an intermediate CA, which is everyone will be trusting this one. And the intermediate CA can issue 2 types of certificates. So one is the server certificate. So this is a node talking to another node will have a certificate of this type. And a client will have a certificate of star clients. And it will use that kind of certificates to connect to the server. So to limit what they can do, I use the roles, as I mentioned before. So we have a role called Kafka clients configured in Vault that will limit this one, and a role called Kafka server on the other side. Okay, let me jump to my terminal now, and let's have a look at what we got. Sorry, I think I need to. Yeah. Right. So if you can see now my terminal, so I have a few types here. So I have a Vault running, and I have a Kafka. So there are 3 nodes here. So I got 3 nodes. Just show that's on this on the screen. So there's a I just deployed the manage. So you can see that there are 3 nodes here. So they are running on localhost. They all different ports, and I have also vaults running here. So I'll go first for Kafka just to double check that it's, so you can see that it's actually running TLS. So I'm just gonna connect this to this port and see what we get from the server. So I'm just gonna go back to here. So if I use OpenSSL just to have a look at the certificates, I can say localhost, the port was 1993, and it's just to have a look at the certificates. I'm just gonna do. So it says here it's connected, so I just connected to node 1. So the certificates in node 1. Oops. Can you actually see the screen? Yeah, so I think I have problems with the share. Sorry, can you see it now?
Yeah, we can see that there, Mateus.
Okay, cool. So I just typed OpenSSL, and so the response from the server is node 1. So this is my server. It was issued by the intermediate certificate. Just go scroll a bit down. So you can see again the server and the client certificates here. So it's accepting client certificates of this type. So whoever is connecting to the server now should needs to provide this certificate. Okay, if we go now to have a look at Vault, so what we have set up. So I have just the UI because it's easier to see. So we have the root CA. It's not the most interesting part. I'll jump to the Kafka CA. So actually we can see the roles here. You can see this. And we have the 2 roles that I described before. So we can actually see some certificates that were generated. But if I have a look at the Kafka client role, we can see that there's a bunch of information here. But this particular role, it allows subdomains of this particular domain, client Acme. And there's also, I've set up like a time to leave for this. So you can all, I think it's 1 hour time to leave. So certificates needs to be, can only be maximum 1 hour. So if I, just to check that this thing works, if I try to generate a certificate using a different name, so if I try to generate something for a server, so using the server pattern, it should give me an error saying that you can't do that. So that it's just showing that actually the Vault is preventing the certificates from being generated. Okay, so what I'm going to do next, I haven't created any topic. So what I'm going to do is I will create a topic in Kafka, and I'll configure the ACL so only a certain consumer and a producer can talk to it. So let me jump back to my terminal. So I have a shell script to do that. So first, I'm just going to configure the ACL, saying, okay, my test topic can only be accessed by my consumer 1. So this is just gonna configure something in Kafka, saying, okay, my test topic, so test topic can be accessed by consumer 1. And now I'm gonna do that same thing for producer 1. So that response goes back, so you can see that my test topic is accessible by those 2. So I'm just gonna clear this, and now I'm gonna start a producer that points to that topic. So start producer, so the topic, and it will identify itself as my producer 1. So just so what's happening here is pretty much I am generating a new token in Vault with that role that I created, Kafka client. I generated this Vault generated me a certificate with the name that I wanted using the my producer 1 argument, and you can see the validity of the certificate's 1 hour, and then I used that certificate to connect to Kafka. So to actually test this, I'm just going to split my screen so I can have a producer on the other side. So I'm just jump to that folder. So if I start a producer on the other side, sorry, a consumer, test topic, and the name was my consumer 1. So it will do the same thing. We'll create a token and a certificate, and you use that to connect. So when you're connecting the topic, so the consumer has connected to Kafka, there's just a warning here because the topic was just created. The client will complain a bit, but it should be working. So if I send, let me just clear this here so we can still running. So if I send something from the producer, you should see on the other side. So the consumer is receiving that, and that's going via TLS with mutual authentication. So now just to show that this is working, so I'm just gonna make this bigger. So if I try to connect to the same topic using some other consumer with some kind of name, I will just try to do that, and Kafka would say, oh, you are not authorized because I haven't configured an ACL for that. But of course, the thing is, you don't want to allow whoever is in a case where you have tenants, you don't want to let anyone just tell what is the tenant that you want to put here. You want some control over that. So what just in our real world example, we actually implemented a slightly different pattern for multi-tenant. So the clients themselves, we had PKI roles per tenant. So we started off with we would have a PKI role for each tenant, where we would replace the tenant here by some ID, and so each tenant would just could only generate certificates of those formats, not anything. But actually, we went further and we did something like this. So each services inside the system could generate for that particular tenant would have something like that. And this gave us some very nice auditing capabilities. So it was enough to know that service X from tenant 1 was connecting to Kafka. The only thing about this is that every time you add a new client or service, you need to create a new role and configure Kafka to allow that role to connect to a certain topic. On the server side, the example that I gave here is actually what we used. So it was the node name .server, and this was good enough for us because we do trust the server a bit more than the clients, and we can actually say, oh, the nodes are okay to generate their names. So there was no need to create new PKI roles for every node. That was too much. And the thing that we did as well, when the server starts up, it will add itself to the ACL so you can join the cluster, because the server actually has access to Zookeeper. Just the last just a detail on here. So it's because when you start configuring many ACLs, just you need to make sure that if you remove something, you also need to remove that from the ACL, so you keep it tidy. The other thing that I wanted just to say what we did as well, it's in terms of the time to leave. So what's the limit for the certificate? So on the client side, we really wanted short-lived certificates. So it's like something like an hour, and that's limited by the PKI role, as I showed you. And so this pretty much we don't need to revoke. So the certificates every hour will be invalid. The only thing you need to have is the clients. They need to be able to do that. So our clients were under our control. We were okay to just detect that the certificates were about to expire and request new ones to Vault. On the server side, it's slightly different. So we had to use something like longer-lived certificates, something like a day or a few days. The reason for that is that on the server we actually have it's Kafka that is running, and it doesn't have the capabilities to actually request or integrate with Vault. So pretty much the renewing certificates actually requires a restart of the broker. And the way we did it was kind of because we generated certificates as well at startup. A single restart will renew the certificate. So if you do a rolling restart of the cluster, all the certificates would be renewed. But the one thing that it's critical here is that you need to monitor what's the state of your certificates, because you need to do this operation to renew the certificate. You can do that in different ways, but it's essential that you monitor and keep renewing the certificates. And in the worst case scenario, you might lose all the certificates, and then no node could join the cluster. And in that situation, it's potential to you can probably lose data. So that you kind of need to plan this scenario. So how we would recover if all the certificates were expired. So I think that was what I wanted to show in terms of Vault PKI. So there's quite a lot to talk, but it's just 30 minutes. So I think this should have given you a good overview. But the Vault PKI is one thing that you can use to, it's not just for Kafka, or it can be used for any TLS-enabled service, so you can consider using that. But it's, in the end, it's all about your use case. So if you might have different requirements, and then that will lead to, you might have different PKI structures, or maybe you don't want to use like a client cert or a client server certificate or mutual authentication. You can mix and match as well. You can you kind of need to define what is best for your use case. But I think what's the most important thing is that Vault here can help you a lot with that, and it was in our case that was really true in our case. And I think, wow, I think I made it on time. So that was my last slide. So, well, thank you very much. This is my contact. So there's a link to the GitHub where you can download this code. There's also a blog post that I wrote, actually going step by step of how we would set this up. There are a few other links here that should give you also more information. Well, thank you very much.